Let's go to Link 2017 grid game. It gave us a 2D array grid, and the grid has size 2 multiplied by n, that is 2 row and n columns. So grid RC represents the number of points at a position RC on the matrix. So there are two robots. The both robots they start at index 0, 0 and move to the bottom right, that is 1, a minus 1. Each robot may only move to the right and down. So only two directions. So it needed the first robot move first, right, from 0 up left to bottom right, and collect all of the points from the cell on its path. And then the second robot is moving from the 0, 0 to 1, 1, a minus 1, collect the points. So the first robots want to minimize the number of points collected by the second robots. And the second robots want to maximize the number of points it collects. So both robots play optimally, retain the number of points collected by the second robots. So for this question, intuitively, what I'm thinking about is that it may have mm, like um, we have two robots, right? So we're thinking about the first intuitively that is, and we trying to there are several things we need to consider. The first thing is that the first robot want to minimize the second points. Second, minimize the points collected by second robots. The question is that if the first robots they try to max, does that equal to the same as the second robot collect the minimum? It's actually not. So for example, we have 2, 5, 5, 5, 1, and 2, for example, 1, 4, and 4, for example, this one, right? So if the first one, they're trying to collect the maximal, he's going to go this way, right? But the thing is that if the first robot, they go, for example, like this way, right? The second can only collect this or this, right? But if even so, the thing is that the first one collect max is not the best optimal approach for him. So what we need to do is that the first one we need to minimize. So how can we minimize that? Actually, for this question, there is a special case that is there are only two rows and n columns. So for the first robots, it has only n kind of passes, right? So the first robots, it can, for example, go down and go right, right? And at index 0 or at index 1, it move to the right and go down to right, right? So it has only n different choices. So for this n different choices, so what left for the robot 2, right? The robot 2 can only choose either the left bottom or upright, right? So he's trying to minimize these two. And what we need to do is that every time we iterate I from 0 to n minus 1, right? We're trying to see the into we can use two variables. One is sum one, right? actually we don't need someone. Someone, and we can call this one as this part as someone, right? And we want to calculate, for example, this part someone and this one sum two. Every time we iterate, the path of first robot going down, right? We try to find the maximum of someone and sum two, and for the that is the local robot tools value, right? So in the global value, we find a minimal value for each for the index where robot one select. So that will return the global minimum, right? So when we write code, we just need to, for example, we can have this, right? And n equals read 0 dot length. So we can have someone first, for example, for let's have long someone equals someone will represent the upper right sum because for robot 2 you can either choose the upper right or lower left, right? So this is someone is sum 2. So let's do this. And someone sum 2 equals to 0, right? And we are going to have a result because we want to have a minimum value. So let's have a long dot max value. So let's int I equals 0, I smaller than n, I plus plus. Then let's have someone should pass equal to grade 0 I. Then we just iterate those kind of paths, right? So let's look at the first case, right? First case, the sum one will minus this kind of I equals to 0, right? And when I, for example, move to 1, right, the sum one just minus this kind of grade 0, 1, right? So every time this kind of index move, this is the path, it is the place where robot going down. Then this someone is trying to minus one values to it. And also the sum two will also add one values to it, right? So what we do is that we need for int I equals to 0, I smaller than n, I plus plus. So we can have sum one minus equal to grade 0, I, right? So for example, we have I here already, right? So a moment ago, this sum one we minus 5, and then sum two will be I minus 1, right? If there is I minus 1 is greater than 0, we add to uh, sum two. So we'll say if I greater than 0, then we'll have sum two to the plus 2 equal to greater 1 R, right? So in this case, we'll say the loan the robot two, right? The robot two for every every pass robot one chooses, then robot two will get this current that will be mass because robot two you want to get um the largest score, right? So sum two. So for our results, okay, let's main result the current. In the end, we just need to return result. Read up someone sum two. Let's take a look. Fine. among minus greater 0 I if I 1. So this will be I minus 1, right? The reason is that, let's see, this is I, right? When this one minus 1, but this one is one index left, right? Um, the Python code will be similar. That's right, Python code. So we're going to have for example, we have n sum 1, sum 2 result. For n will be length of grid 0, right? And sum 1 will be sum of grid 0. And sum 2 will be 0, right? Result will be, let's set out maximum big value to load. So what we do is the for I in range, and we're going to have someone should every time we move this kind of divider, right? Move this divider, our someone, we're going to remove one value to it, and we'll move here someone will move one value to it, right? And sum two, if there is a value here, then we'll add the I minus 1 index. So we'll minus grid I I 0 I, right? So let's say if I is greater than 0, um sum 2 should positive to grid 1 I minus 1, and we'll have current equals to max sum 1 sum 2, right? So that is for this path, robot 2 will get the value to be current, right? So our result, we're trying to get the minimum of result in current. In the end, we just return result. Doing like this, it will be O in time complexity and a constant space complexity.